The topic of this video is analyzing the graph of a rational function. Let's solve this problem. R of x equals x squared over the denominator x squared plus x minus 6. Okay, we know we've got to make it through these 6 steps, so let's begin. Step 1 is domain, and with domain we care about the denominator. We want our denominator to be not 0. We don't care about the numerator. 0 in the numerator is okay. It's 0 in the denominator that we're worried about. We're solving this by factoring. So this is a trinomial. It's in descending order. It's a simple trinomial, meaning that the leading coefficient is 1. And for that reason, we just have to come up with 2 numbers that multiply to make -6, but add to make +1. Those numbers are -3 and +2. Putting an x in front of each one of those and creating our factors, we get x minus 3 times x plus 2. We can check this with FOIL. X squared plus 2x minus 3x. Nope, I got the signs backwards. This is why we check. Okay, so swapping the signs, x squared minus 2x plus 3x makes plus 1x, and then 3 times -2 is -6. All right, next, zero product property. X plus 3 is not equal to 0. X minus 2 is not equal to 0. So x is not -3, and x is not 2. So our domain for this problem is the set of all x such that x is real, but it is not equal to -3, and it is not equal to 2. All right, that was it for step 1. Step 2, we're looking for holes. All right, so what are the steps for finding holes? Factor the numerator of r, write r in lowest terms. Any canceled factors will create a hole on the graph. All right, so let's write this in its factored form. X squared is the same thing as an x times another x. And we just factored this trinomial a moment ago, and we got x plus 3, x minus 2. There are no factors in common, top and bottom, which means there are no factors that cancel, which means there are no holes. So there are no holes in this particular graph. All right, that moves us on to step 3, intercepts. All right, intercepts come in 2 flavors, x and y. Let's start with finding the x-intercepts. The most important characteristic of an x-intercept is that y equals 0. And we know that for this equation, r of x equals this fraction, we could write y equals this fraction. So when we replace y with 0, we're really replacing the left-hand side here. So we get 0 equals x squared over x squared plus x minus 6. Now, the only way a fraction can ever equal 0 is if its numerator equals 0. So this gives us x squared equals 0, or if we prefer x times x equals 0, and by the zero product property we get x equals 0, x equals 0. The reason why I've done it this way and written it this way is because the multiplicity is going to tell us what happens to the graph at 0. Even, so we say even touches odd crosses, so it's going to touch the graph and bounce away when x is 0, y is 0, so we get the origin, and it touches at the origin. So our x-intercept is 0, 0, and it touches at that location. Okay, y-intercept. Well, with a y-intercept, x is equal to 0, and so we plug in here, and we get y is equal to 0 squared over 0 squared plus 0 minus 6. Numerator 0 squared is 0. Denominator 0 squared is 0. Plus 0 is 0. Minus 6 is -6. And 0 divided by -6 is 0. So once again, I get the origin 0, 0. And we already know what happens there. So the y-intercept and the x-intercept are the same point. They are the origin 0, 0. And we'll find that the graph will touch there and bounce away. All right, great. So we've done the first 3 steps. Now we're going to move on to the remainder of the steps in our next video.